In this example, I'd like to consider a tension compression bar with constant AE that's subjected to a distributed body force B of x. And B of x has the property that it's 0 from the wall out to some distance A. And then from A out to the end of the bar, it increases parabolically to a final value of B naught. So B naught has units of force per unit length. And so we can write it as shown here using Macaulay bracket notation. So I have B of x is equal to B naught times the Macaulay bracket of x over a minus 1 squared divided by L over a minus 1 squared. So the divisor there is designed so that I hit the terminal value of B naught. So to determine the deformation of the bar, I can look at the governing equation. AE u double prime is equal to minus B naught x over a minus 1 Macaulay bracket squared divided by L over a minus 1 squared. And now I can integrate twice and apply my boundary conditions. So AE u prime, which is the internal force, is equal to minus B naught x over a minus 1 cubed L over a minus 1 squared. I need a factor of 3 to account for the 3 up there. And because of the a inside the argument here of the Macaulay bracket, I'm going to pick up a factor of a plus C1 constant of integration. I can integrate one more time. AE u double prime is equal to minus B naught a squared Macaulay bracket x over a minus 1 to the 4 over 12 L over a minus 1 squared plus C1x plus C2. Boundary condition u of 0 equals 0 is going to tell me that C2 equals 0, and that's because the Macaulay bracket of minus 1 is 0. Out at x equals L, I know that the force is equal to 0, the resultant force, it's a free end. So that is going to tell me that C1 is equal to B0A L over a minus 1 cubed over 3 L over a minus 1 squared. So that is B0A L over a minus 1 divided by 3. Macaulay bracket of a positive quantity is the quantity. So now I can substitute back in and I can write down my expression. There's an error here. This is not double prime. It's AEU. So I have the deflection u of x is equal to 1 over AE times. And let's go ahead, and when we write this, let's go ahead and factor out a B0A squared from both terms. I think that will make it look a little bit nicer. So we'll have minus 1 over 12 L over a minus 1 squared, Macaulay bracket of x over a minus 1 to the 4th power plus 1/3 L over a minus 1 x over a. So that gives us our final result for the deflection. And maybe we can check the dimensions. If we look at this term in the square brackets, everything in the square brackets is non-dimensional. And the front factor over here, B0 is force per unit length, and AE is force, so that's per unit length there, B0 over AE. And we have length squared in the numerator, so we get dimensions of length. So that works out perfectly.